All right, here's our second question. Let f be the function given by f of x equals sine of 5x plus pi over 4, and let p of x be the third degree Taylor polynomial for f about x equals 0. Find p of x. So here's the thing. P of x is a third degree Taylor polynomial centered at 0. This function not centered at 0. Okay, so we can't just blop. We can't just write out the Taylor series for sine and then blop 5x plus pi over 4 in, because that'll give us a Taylor series not centered at 0. So what we need to do instead is write ourselves a little chart. We're going to have to go up to the third derivative. Okay, and our function is sine of 5x plus pi over 4. So our first derivative would be cosine of blop times the derivative of the blop, so times 5. And our second derivative is negative sine blop times the 5. But we already had a 5. 5 times 5 gives us 25. And then our third derivative is negative cosine blop times 5 again. So now we have 5 times 5 times 5. Okay, and then since we want this Taylor polynomial centered at 0, we're going to plug in 0 for each of these. So we have sine of 0 plus pi over 4, which is square root 2 over 2. We have 5 times cosine of pi over 4, which gives us 5 on the square root of 2 over 2. When we plug here, we get negative 25 on the square root of 2 over 2. And we plug that into our third derivative, we get negative 125 on the square root of 2 over 2. Okay, so writing out our third degree Taylor polynomial gives us the square root of 2 over 2 plus 5 on the square root of 2 over 2 times x minus 25 on the square root of 2 over 2 times 2 factorial x squared minus 125 on the square root of 2 over 2 times 3 factorial x cubed. This is really times 1 factorial back here. We just didn't write it. Okay? And believe it or not, that was worth 4 points. Good for us. Part B says, find the coefficient of x to the 22nd. Oh my goodness gracious. Well, when we're looking for x to the second, we get 25 over square root of 2 times 2 factorial, right? When n is 3, we get 5 cubed, or 125, happens to be negative, on the square root of 2 over 2 times 3 factorial. So when n is 22, I feel like we're going to get 5 to the 22 on the square root of 2 over 2 times 22 factorial, and that is correct. Now, here's the big question. Is it positive or negative, right? Okay, well, if we look at our chart up here, the 0th term and first term are positive. Okay, second term and third term are negative. 4th and 5th are positive. 6th and 7th are negative. So it seems like our 0th term, our 4th term, our 8th term, our 16th term, all the multiples of 4 are going to end up at the top of the chart, okay, including 20. So our 20th term is positive, our 21st term is positive, our 22nd term is going to be negative, okay? Part C. Part C says to use the Lagrange error bound, which, by the way, that's another way of saying Taylor's inequality. Okay, Lagrange and Taylor, two different guys, came up with the same thing. To figure out, or to prove, I should say, that f of 1/10 minus p of 1/10, all that means is our actual value minus our Taylor polynomial value, our estimated value, is less than 1 over 100. Okay, so we're going to write down Taylor's inequality. We want to say that this is going to be less than or equal to some m, which we'll figure out, divided by 4 factorial. Why is it 4 factorial? Because we used a third degree Taylor polynomial. Okay, so n plus 1 would be 4, times x minus a, or the farthest you get from your center. We're evaluating it at 1/10. We're centered at 0, so we are 1/10 away from our center, to the n plus 1. Now, what is m? That's the question. That's the tough cookie, right? Well, m is an upper bound on our fourth derivative. Okay, so we need to figure out what is our fourth derivative. If we go back up here to our chart, we went as far as the third derivative, right? So let's go one more. The derivative of negative cosine would be positive sine of BLOP, 5x plus pi over 4, times 125 times 5, which is 625. Okay, so we have 625 times sine of BLOP, right? So here's the thing. We know that sine only gets as big as 1. Now we could be more exact, right, between negative 1/10 and positive 1/10, but we don't need to, right? That is a good upper bound. Times 625 gives us an m value of 625. 625 times 1. So we're saying that 625 over 4 factorial times 1/10 to the 4th is less than 1 over 100. Our error term is less than 1 over 100. And believe it or not, that was only worth 1 point. Wowzers. Part D says, what does Part D say? Part D says that capital G is a function given by the integral of f, right? The third degree Taylor polynomial for G. So we're writing the third degree Taylor polynomial. Here's the thing. We have the third degree Taylor polynomial for f, and we know that G is the integral of f. So let's just integrate this series term by term by term. So we get square root 2 over 2x plus 5 on the square root of 2 over 2 times 2, oops, yes, x squared minus 25 on the square root of 2 over 2 times 2 factorial, which is 2 times 3 x to the third. Okay, so we actually don't even have to go up to, we don't have to integrate our third degree term because we'd get a fourth degree, and we only want the third degree Taylor polynomial for G. That was worth 2 points, Part D. So A was 4, B was 2, C surprisingly was only 1, and Part D was worth 2. So I hope you guys did well on that one. I'll send you the last question in a little bit.